Okay, so we're continuing the Unit 2 test review. It's the 2.4 motion in a plane test that's coming up, and this is number 9. And I have a few issues with this particular problem. So vector A is describing as having a magnitude of -7. So vectors should never have a negative magnitude. They can have negative direction, but never a negative magnitude. So that's kind of an issue at first. And then an angle of 30 degrees, which is an equivalent statement of magnitude and angle vector A. So what we have to do is first subtract 180 minus 30 to get 150. Okay. And then we have to reverse the sign of the vector. So we'll have a +7. So this is going to go away, this one, and this one. And since we are coming from the oops, I crossed out one I wasn't supposed to cross out. So sorry. Let me see if I can erase that. I got excited about it. Okay, so I need something with a +7. And then it says, if we are going from counterclockwise, the x, so this vector, if I have this, and this is at 30 degrees, then if I am going counterclockwise, it's going to be, it's 150 degrees here. We'll just do this. It's 150 degrees. Okay, and this one is also very similar. This is number 10. So I have a magnitude of 5 and an angle of -20. And what that looks like to me is this is 20 degrees and this is 5. So I know that the first thing I have to do is subtract 180 minus 20, which is 160, which is this angle. So I'm going to get rid of these. And then I need, and this one here. And then I need the opposite, or to reverse the sign of the vector. So it's going to be this one. Okay. This was a fun one. So it says a projectile is fired. We have our given is VOX is equal to 140 meters per second. VOY is equal to 84 meters per second. And Y is equal to 20 meters. And I put this, this diagram in down here to kind of show you how the velocity vectors in a projectile motion problem go. And here's a link if you want to go see it. But basically, if this is my VOY, this is my VOX, you'll see that this becomes VY and VX. VX doesn't change. And then here at the top, Vy is 0 because it's not, there is no velocity in the y direction. And then you'll see that it flips. The Vy becomes negative, and we still have the same Vx. So what I did, it says what is the horizontal component of the velocity at point P, which is right here. Well, the horizontal component of velocity remains the same all the way through. So the horizontal component of velocity is going to be 140 meters per second. Okay, this is the same picture. And this one we're going to be doing some calculations on. So given that VOX, same as the one we just had, VOY is 26, and H is 20. we are looking for, it says the horizontal distance that the projectile travels. So we are looking for x. Let me change colors. Okay. So what I did was I solved for t, or time, solved for time. And the way I did that was I said, okay, y is equal to 1/2 acceleration in the y direction, t squared, plus VO yt plus YO. Okay, and then y is equal to 1/2 9.8 t squared plus, and this is a negative because gravity is negative, 26t, because that's what we have up here, plus 20. Y is equal to negative 4.9 t squared plus 26t plus 20. Y is 0. Our initial point here is going to be, our final point is going to be 0 because we're on the ground. So this becomes a quadratic equation. And I'll just show you how I plugged it in. So solving for time, the quadratic equation is something hopefully you guys are familiar with. So I have negative b, which is 26, plus or minus the square root of 26 squared minus 4 times negative 4.9 times 20 over 2 times negative 4.9. I'm kind of running out of room here. Let's see. So I ended up with negative 26 plus or minus 32.68 over negative 9.8. Now here's the kicker. Time cannot be negative. So I have to choose the negative 26 minus 32.68 and then dividing by the negative to give me a positive time. And I end up with time is equal to 5.98 seconds, and we're going to use that to find our x. So what we're going to do is we're going to come up here. Velocity is equal to distance over time. So if I'm looking, if I'm looking for distance, or x, I'm going to multiply velocity in the x times time. So that's going to be 310 times 5.98 seconds, which is 1,856 meters. Now, that's not this one and that's not this one, but this is 1.9 kilometers. All right. Okay, rescue plane. Okay, a rescue plane is flying horizontally at a height of 97 meters. It drops the kit with a vertical acceleration of negative 6.63 meters per second squared, horizontal speed of this. So let me write what I'm given, and so we can figure out what our unknown is. I'm given, and I drew a picture here. So here's my airplane. Oh gosh, guys. It's okay, great, lovely. This is 97 meters. And I know that my acceleration in the y direction is negative 6.63 meters per second squared. And my velocity in the x direction is 66.4 meters per second. So the first thing I'm going to do after I change my colors is find t. Find time. I'm looking for x. Or actually, I'm going to be looking for range or distance. So find time. So I'm using y is equal to VOYT plus 1/2 AT squared. This is 0 because velocity in the y direction is 0. My y is 97 from right here. 1/2 the 6.63 t squared. And I'm using a positive number here because time has to be positive. Once I multiply this and divide, I'm going to have to square root it, and I get 5.41 seconds. So it takes 5.41 seconds to hit the ground. So my range is equal to my horizontal distance, or x for that matter, and that is equal to speed times time. So again, we have velocity is equal to distance over time. I'm looking for distance, so it's velocity times time. I have my my time here. I have my velocity here. I'm going to plug those in with not yellow. So this is 66.4 meters per second times 5.41 seconds, which is equal to 359 meters. So that's right here. Okay. Aha, got it. This was an interesting one. You throw a rock off a cliff with an initial speed of 20. After 2 seconds, what's the magnitude of the velocity? Okay, so I kind of drew this. This is the rock, throwing it off the cliff. Vox is equal to 20 meters per second. Acceleration in the y direction is 9.81 meters per second. Time is equal to 2 seconds. Not meters, seconds. Yay. So I used, to find my v in the y direction, I used v initial plus at, which is v initial is 0 in the y direction, because it's all in the x direction there. So I have 9.81 times 2, which is 19.6 meters per second. And then what I did was I made a triangle with my velocity vectors. So I know that this is 20 meters per second because this is the v and the x. V and the y is going to be 19.6, and I'm looking for this velocity. Okay, so then it becomes a Pythagorean theorem thing. 20 squared plus 19.6 squared is equal to c squared. C ends up being 28 meters per second. Okay, last one. Let's hoping we can get the last one. Okay, a boy throws a rock at a given velocity of 2.15 meters per second at 30 degrees above the horizontal. I drew this because just to see, he threw the rock. It went like this. This is 30 degrees. The velocity vector here is 2.15. How long? So I'm looking for time. I'm given these things. My unknown is time. Time to max height. So actually it's just time to here. Time to max height. It's not time to the ground. And there's a formula in your lesson that says that to find this time to max height, because this is a special time when it comes to when velocity in the y direction is 0. This time to max height is equal to initial velocity times the sine of theta over gravity. So we have initial velocity, which is 2.15, times the sine of 30 over 9.81. And I got which is closest to this. All right, that's the last one. Let me know if you have any questions.